All right, just kidding. I still have more to do on number 2. So let's finish number 2 on the next page. So on B, we want to find all the values of the graph at which the graph of f has a point of inflection, and they give the reason for our answers. So don't forget, when we're talking about point of inflection, that's where the concavity changes, and to get that, we are going to need to have the second derivative. So I'm just going to rewrite my first derivative here, and then we'll find it together. Okay, so we are going to need to do the product rule to find this derivative. Okay, so we will leave the first part alone and then multiply by the derivative of e to the x, which is just going to be e to the x, right? And then we'll leave e to the x alone and multiply by the derivative of the second factor. Sorry, my dog won't quit barking. All right, then we want to find when this is 0. So the best thing to do is to factor out an e to the x. All right, so we factor out of the first, what's in front of the plus sign, we get that. We factor it out of what's after the plus sign, we're left with 2x. And then I'm going to set it equal to 0, kind of rearrange it a little bit. Okay, so we're kind of back to that same thing we were talking about when you multiply. The only way to get 0 is if one of the factors you're multiplying is 0, and e to the x can never be 0. Sorry, I wrote that wrong. So we don't need that part when we're trying to find what makes the second derivative 0. So I would just take what's in the parentheses. Now that fraction is annoying, but we can get rid of it if we just multiply through by 4. Okay, and then we'll just factor this real quick. Oops. And we're going to get 2 values that make this second derivative 0. Negative 5/2 and 1/2. All right, and so I don't have very much room, but I'm going to try to squeeze it on here. We're going to do a sign chart. Right, and then we'll test points in each region. So negative 5/2 is negative 2.5. So we'll put in -3. We'll put in 0, and we'll put in 1 into the second derivative. Great. Now, no matter what, remember this e to the x is positive. So we really just need to worry about these 2 factors. So if I put in -3, I'm going to get a negative for the first factor and for the second factor. So when I multiply, a negative times a negative is a positive. For 0, I can put it in the non-factored form. So this part right here, so I know I'm going to get a negative. And then for 1, I'm going to get a positive times a positive. Oh, hold on. Positive times a positive, so that's positive. And I haven't left myself room to do the reasons. All right, so I'm going to write it up here. Hopefully you guys have room. So the question was to find all of the x values of the points of inflection. So at negative 5 halves, our second derivative changes from positive to negative, so that creates a point of inflection when x is negative 5 halves. And then at 1 half, the second derivative changes from negative to positive, so that's another point of inflection. So my answer is going to be up here. So I'm going to say because f double prime changes sign at x equals negative 5 halves and x equals 1 half, the graph of f has points of inflection. There. Now you can't just say the graph, because it could be the graph of f prime or it could be the graph of f double prime. So make sure you say the graph of f has points of inflection there. Okay, and then see, I like these problems like C. So we're going to fill in the missing entries in the table below, and we're going to describe the behavior of G prime and G double prime in the intervals from -3 to 3. Now, some of them we have answers already. So we know what G prime, G double prime is at -3, at 0, and at 3. We're going to fill in those other blanks. So G is the graph we've kind of been ignoring. All right. And so in the interval between -3 and 0, the graph of G is, I would say, it's already in there, positive, because it's graphed above the x-axis. Right? And then G prime would be the graph of the slopes of G. And so if you look, all of these little slopes in that interval are positive, so it would be positive. Right? And then if we look at the second interval from 0 to 3, same thing. All are positive slopes. All right, so let's write down y. So we would say G prime of x is positive from -3 to 0 and 0 to 3 because the graph of G is increasing there. Okay. And then if we're going to figure out the second derivative, if it's positive or negative by looking at the graph, what we need to look at is the concavity. So in that interval from -3 to 0, I would say that graph, that part of the graph is concave up. And if G is concave up, the second derivative is positive. So G double prime is positive from -3 to 0 because the graph of G is concave up there. All right, and then our second part that we need to fill in is the second derivative for our final interval, which is from 0 to 3. And on that interval, the graph of G is concave down, which is going to make the second derivative negative. Now, again, it's so important that you're very specific about what you're talking about. You can't just say it. You can't just say the graph, because there are 3 different functions we're talking about here, so you have to name them all. All right, and then D is something that we haven't really talked about in a while, so this is a good review question. So H is a brand new function that's bound by multiplying f times g. We want to know, is h increasing or decreasing when x is 0, and we want to give a reason. So we need to remember that if we are talking about where a function is increasing or decreasing, we need the first derivative. So we need h prime of x. Right? And then to find h prime of x, we're basically just going to write out the product rule. So we would leave f alone and multiply by the derivative of g, and then leave g alone and multiply by the derivative of f. So you'll get points for just writing out the product rule. Then we would get points for filling in the value we want, which is 0. Okay, so what I want y'all to do is go through your functions f and g and fill in f of 0, g prime of 0, g of 0, and f prime of 0. So pause the video, get that written, and then check back with me. All right, so for the G, it's pretty easy because it's right there on the table for us. For F, we need to go back and look at some things. So F prime of 0, we're told, is -1, or F of 0, sorry, is -1. And then for F prime of 0, you would need to plug in 0 for X. You don't necessarily have to show that work. But if you're confused about it, I want to do it real quick. All right, so 0 minus 5/4 is -5/4, and e to the 0 is 1. Okay. And so h prime, that's going to be -2, and then it's going to be minus, 5/2. So a negative minus the negative is definitely going to be a negative. We don't need to know exactly what that value is, but it's a negative. So that would mean that h is decreasing at x equals 0 because h prime of 0 is negative. Okay, now I'm done. And you guys can work on the rest of your review.